Hello, and welcome back to our second maths lesson today. Today we're going to be continuing to look at adding fractions, but we're going to be looking beyond one. So you're thinking about whether any rules change or what we might need to know in order to show it. Give you a hint. Everything's the same, apart from the fact that we can use our mixed numbers and improper fraction skills. That's it. We do exactly the same as we have done all the way through, and then convert them to mixed numbers or improper fractions, depending on which way you want to look at it. So all you're doing is linking two of the skills that we already have together. I'm sure every single one of you can do this, hopefully without too much of a problem. We just need to remember the rules that we had. In order to add a fraction, we need to have the same denominator, and then we can add the numerators together. And the next bit after that is we just need to make sure that when we're using mixed numbers, we just divide the top by the bottom and see how many we have. And whatever the remainder we have is the amount of fractions that we have left of that denominator. Let's have a look and see what we can do. So, first one. Here's two questions. Have a go, see what you think, and then we'll talk it through. Off you go. Okay, so let's have a look. The first one, obviously, these are all additions or equivalent fractions, which is number 3. What we're doing in the first one is we're looking at adding a half to a quarter to a half. Now we need to get these in the same fraction. So 2 goes into 4 twice, so we need to times that by 2, which is 2 quarters. The same with this one. This one is a half, so it's also going to be 2 quarters. The bottom, therefore, is going to be quarters. So it says we've got 1 1/4. Let's have a look. 2, 1, and 2. We've got 5 quarters. 5 divided by 4 is 1, remainder 1. So that is 1 with 1/4. Remember, 4/4 is 1. We take 4/4 out of that. We're left with 1 left over. And there it is. And there it is. Also, half plus a half is 1. That leaves us with a quarter, which is a quarter. The next one down here, 5/7, 3/7, and 4/21. Well, 5/7 and 3/7 we could transfer it into 21s. We're timesing it by 3, so this would be 15 21s, and this would be 9 21s, and then we can add them all together. 15, 4, and 9. So it's 24 plus that is 28 over 21. And then obviously we get that. We could, if we want to change this into a mixed number, take 21 out, gives us the 1, and that means we're left with 7. So we could say it was 1 and 7 21s, like that. The next thing over here, this is equivalent fractions. So what have I done to 5 to get to 15? Or times it by 3. So I've got times the dot by 3, which is 3. What have I done to 1 to get to 9? I times it by 9. So I must times the bottom here by 9 as well. So 5 times 9 is 45. And there, 3 and 45. You can have 1/3 if you wanted, because that's both of these two are divisible by 3, by 7 even. So 7 goes into 7 once, and 21 goes into 7 goes into 21 3 times. So you get this a third. I'd be happy if you kept it like this. So just a quick recap of what we're talking about before. This is addition of fractions. This is going beyond 1, but the rule says the same. So the first thing you think about in terms of these two is getting the same denominator. So 3 goes into 6, so we can just times this fraction by 2, because that's how many 3's go into 6, and we get this one, and then we can add them together. But we can't just add on to the end. We need to move it into the next column. This one actually should be here, look. And then we've got 1, 2, 3, 4. On top of that, that's 1 whole 1 and 3/6. 1 whole 1 and 3/6, or 9, 6 in total. 3/6 actually is the same. Look, there it is. That's 1, 2. It's a half. So we could also write it as 1.5. Here's our next one. We're going to put it in terms of eighths. So 4 goes into 8 twice, so we times it by 2. 2 goes into 8, so we times by 4. Then we could use a bar model to show it. There's our 7/8. Add on the others like that. The 6, 1, 2, 3, 4, 5, 6. Then an additional 4, which actually means we need to fill in another bar. So we've got our 7 there, our 6 and our 4. That gives us 2 whole ones and 1/8. This is why bar model is useful. Obviously, 6 plus 4 is 10, plus 7 is 17. That's where we get that from. And then we've got 2 whole ones and 1/8, which is there. So here you go. Here's 2 questions. Have a go, see what you think. Okay, so let's have a look. The first one here we can do in 18ths. So first thing we do is put this in terms of 18ths. So we're going to times it by 2. Both those times by 2, 18, 10 18ths. Then we put our 11 in plus our 10, which gives us a new bar with 3 in it. So we're looking at 21 18ths, which is the same as 1 and 3 18ths, because 10 plus 11 is 21, so 21 18ths. Then we've got 1 whole one and 3 extra ones, which is 1 and 3 18ths, which is here. But then we can also divide both of these 2 by 3. So if we divide 3 by 3, we get 1. If we divide 18 by 3, we get 6. Because both can be, we can simplify it to 1/6. Now remember, I'm happy with either answer. So, because we haven't said you have to simplify. But that's just the next step that you will definitely be asked to do. Then the next one, we can put them all in terms of 24ths, or we can put them all in terms of 12ths. It's up to you which way you go. But if we would put them in terms of 12ths, because it's easier, 6 goes into 12, 24 can be divided by 2, or you can go the other way around, and we'll talk about that in a minute. Then we can add them all together to get 26 12ths, which is the same as 2 whole ones and 2 12ths. 2 whole 12ths, we take 12 away, and we still have 14 left. We take another 12 out, which is our 2 whole ones, and we're left with 2, and that gives us this. We could also then simplify this. Both of these 2 are divisible by 2, so it's the same as 1/6. Now, if we were to do that the other way around, so 11 12ths we could say is the same as 22. Sorry, I'll write it over here. We times both by 2 is 22 24ths. We add that on to 10 24ths, and 6 we have to times by 4 to get to 24. So we've got to times the 5 by 4 to get to 20. Then we can add them all together. 22 plus 20 is 42, plus 10 is 52. Then you could divide that by 2, all of it by 2 to get any, because both are even. That gives us to 26 12ths, and that leads us straight back into exactly what we've done before. So it doesn't matter which way around you do it. Yeah, actually, the answer you get is the same. You could have the answer written down like this, like this, like this, preferably with a mixed number in it. Okay, here are some questions. Have a go, see what you can do. Pause now. Okay, so let's go through the answers then, shall we? The first one, we're using bar models to help us. So we do a half, which we can see here, or the same if we're thinking in tenths, it'd be 5/10. Add that 7/10 on. There it is. You've got 12 in total, which is the same as 1 whole one and 2/10. So you could have 1 and 2/10, but 2 and 10 both are divisible by 2, which gives you 1/5. This one, you've got 1/2, which is 5/10, plus 3/10, plus 5/5, which we need to put into tenths, which is 2/10. We've got 10/10 in total, which is the same as 1 whole one. Next one down here, all of these numbers go into 12ths. 3 goes in 12 times in by 4. So 2 times 4 is 8. There's the blue bit. Then we got 5/6. Well, we times it by 2 to get to 12. So that means we times it 5 by 2 to get 10, which is the red bits, plus the 1, which is there. Then we've got 19 in total, or we've got 1 whole 1 and 7/12, which is there. So using the same principle or any other method, you could draw them out if you wanted to, or you could just keep going through them. These would be the answers you get. And remember, some of them will be simplified. So this one's into fifths rather than 20ths, because if we take 20 out, we're left with 12 20ths. So you could have 12 20ths as your partial fraction, not 3/5. Or you could divide that by 2 and have 6/10 or 3/5. It's the same thing. In this one here, you could leave it as 12ths. 2/12 would also be 1 and 2/12, or 1 and that and 1 and that. Over here again, this is in 12ths. So if you take 12 away from this, you're you take 12 away, you're left with 9/12. Both are divisible by 3, which gives you to this one. So you could have the answer being 1 and 3, 9/12. This one you're in 15ths. Take 15 away, so you could have 1 and 5/15 as well. And this one here again, you're in 15ths, taking 2 whole 1s away, because you can take 2 15s in, which is 30, and so you could be left also with 6/15 as well. And all you're doing is thinking about what these numbers are both divisible by. So these are divisible by 3, which gets you to this. These two are divisible by 5, which gets you to this one. So I would accept any of these answers as correct. And then matching them, you just have to look at each side and match them. And this is the pattern they make. Okay. So now for a worded question. So either has some bottles of lemonade, water, and apple juice. So 3 bottles. The bottles have a mass of 3 kilograms altogether. So in total, they're 3. The bottles of water has a mass of 7.8 kilogram. Oh, not 7.8, 7/8 kilogram in total. And each bottle of lemonade has a mass of 11/16. She has 2 bottles of lemonade. So the question is, how much do all the bottles of apple juice weigh? So what we're actually looking at, and there is a piece, lots of pieces of information here, but what we're saying is the total is 3. Yeah. Then you've got how much you have in water, total, how much each bottle of lemonade is, and then needing 2, and then thinking about what the missing number is. Have a go, see what you can do. Okay, so let's have a look. Our total is 3. I'm going to leave the kilograms out for the moment. That is made up of a mystery number, something. We've added on here 2 extra bits. This is 7/8, that's in total. So 1 is just 7/8. And the other one, it says each bottle of lemonade is 11/16. There are 2 bottles of lemonade altogether. So we've got 2 of those. 2 11s make 22. It's still 16ths. And then we can think about that. Now, the easiest way to think about this, both of these 2 go into 16, or we could put this as 8, but let's go to 16 because it kind of helps us. So we're going to put this in terms of 16ths as well, but we don't know what it is yet because we need to know what this is. Times this by 2, so it's 14/16. We also need to know what 3 whole ones are in terms of 16ths. So what we do is think about what would the improper fraction be. Well, 3 is 3 whole ones, so it's 3 lots of 16/16. So 3 times 16 basically. So the first one is 16, then we add another 16 on to get to 2 whole ones, which is 32. Then we add another 16, which is 48. Yeah? We'll go through it again. 3 whole ones, 3 whole 16s. 1 whole is 16/16. The second whole is 16/16. The third whole is 16/16. 16 plus 16 is 20 plus 12, 32. Plus another 16, 32 plus 10 is 42, plus 6 is 48. Then we work backwards from there. We take away these two parts to find the missing part. So 48 minus 14 is going to be 34. Take away 22. So 34 take away 22 is going to be 12. So we imagine our missing number should be 12/16. So let's have a look. We know all of them together equal 3. We know the weight of the water is 7/8. We know the lemonade, each one has 2 of them. Both are 11/16. How much the apple juice weighs, that's our missing part. So that's the same as 4/16. Add those two together. We get 11 plus 11 plus 14 is 36. And the difference is 12/16. You can work it out either way, but that's what I would do. So if Ada has 3 bottles of apple juice, what is the mass of 1 bottle of apple juice? Have a think. What do you think? Yeah. So all we need to do is take 12/16 and divide the 12 by 3. We get 4/16 each, or 1/4 of a kilogram each. Here's our next question. We've got 5/8 plus 2/7 plus 3/8. This causes a problem because the 8s and the 7s don't go into each other. But what we can do is reorder it because addition can go in any order. So we add our 5 and 3/8 together, which equals 1. Then we can just add the 2/7 on because we've come away from the fraction. Now, this is a bit of a tricky, sneaky one because unless you saw that already, you might not know that, and you don't have to do anything complicated really, but it might just catch you out. Have a look at this one, see if you can see the sneaky way to do it. Okay, let's have a look. Well, these two go together. They both go into 18ths or 9ths, in fact. Divide 4/18 by 2 and you get 2, or times 7/9 by 2 and you get 14. Add it together, you get 1, and then you've just got 3/13 left. Okay, how about this? Well, there's multiple ways you could solve this, really. You can put them all in terms of 24ths, obviously. Now, the thing to remember is 29 needs to be split over all of those. Now, these two have to be thought of as this one has to be times by 6 to get there, and this one needs to be times by 2. So, in essence, whatever we put here, we have to think about it fitting in. So, if we take 3 out, this has to be 26 in total, which would be 14 and 12, and that'd be 7 and 2. But you could do it in multiple different ways, because if I put a 1 here, so let's go back. If I wanted to put a 1 here, if I put a 1 in here, that's 1, that's 6. Then between these two, I've got to fit 29 minus a 6, which is 23. So, and I can times by 2. So 23, if I took 3 out, I could put 10 here, which, sorry, I can put 20 here. That's the 23 that we got, plus the 6 is 29. 20 times divided by 2 is 10. So there's multiple ways you can answer it, and it's really just working out. You can even change the way you've done this as well. There's so many different answers. You just got to think logically about it. So here's your set of questions for me, please. Pause now and have a go. Okay, so let's have a look at the answers. So here's our answers for this one. So we've got Dexter had some food, tins of food, and there are 4 types of food. There's beans, sweet corn, soup, and tomatoes. The total weight of all the tins is 2 kilograms. The beans, all together, the beans weigh 2/3. The sweet corn weigh 5/12, and the soup weigh 4/4. We'll work out the total weight of the tins of beans, sweet corn, and soup. So we're adding 2/3, 5/12, and 1/4 together. Put them all in terms of 12ths, or is easier. So times it by 4. gives us 8/12 plus that 5/12 plus we have to times a quarter by 3 to get to 12ths. It's 3. So in total we've got 8, 11, 16. Take out the 1, 16. That leaves us with 4 quarters, 4/12. Both 4 and 12 can be divided by 3, by 4 even, to give us 1/3. And that's the answer there. Then how much do the tins of tomato weigh? So they're the ones left over, the ones we don't know. So we're taking 2 kilograms, working out what 2 kilograms is the answer. So we've got 16/12 if we take this answer, or obviously we can work it out as 1 and 1/3. We're adding something onto it and we're getting 2. Well, we're just adding, what do we need to add on to 1/3, 2/3 to get another whole one? Well, 1/3 plus 2/3 equals 1 whole. 1 and 1 equals 2. So the missing bit must be that 2/3. And then we got addition pyramids. And what you do is you add these 2 bits to get that answer, these 2 to get that answer. And there's your answer. And again, this is the challenge question. So don't worry if you didn't manage it, but well done if you did. And that's it. We've got one more, 3 different possibilities, another little challenge question. Other than that, well done. As you can see, it's just using what we already know and just putting the pieces of knowledge together. Now, obviously, we'll go through this multiple times anyway, because as you can imagine, it builds and builds and builds. But just think about the 2 different things: adding fractions, getting the same denominator, and then mixed numbers is splitting it down to get each individual whole one, and then thinking about what's left. Hopefully that was all right. Good luck. I'll see you in the next video. Goodbye.